video. Hi class, doing this video using the Microsoft HoloLens, which I am wearing, and is an augmented reality device, and you are seeing what I am seeing, which is my paper. You may see me interacting with the computer with spoken commands or hand commands as we go through this. There is a 5-minute limit, so after 5 minutes it'll stop and I'll continue with the multiple choice. In part 1, this is a Doppler effect question. The person standing up there on top of the cliffs is the observer, and the person falling is the source of sound. As they fall, the waves behind them expand, and that should tell you, lead you to the proper answer. And they keep falling, and they keep increasing their speed, and they keep expanding. In question number 2, you should note that the sound waves transfer energy. They're mechanical waves, and they do so only in the presence of matter. And if there's no matter, such as outer space, sound waves can't transfer energy. So string 1, in the absence of air, which is the matter, will still vibrate. But you need to think about, if there's no matter, is there any way to transfer energy to string 2, which would lead you to the correct choice. In question 3, it's the wave equation, V equals lambda F. From the notes, you'll note that frequency does not change when sound enters a new media, so you could make up a frequency. You know in air that sound is 343, and you know from the notes that in water it's much faster, like 1500. So you could do initial and final conditions there and determine what happens to the wavelength. That would lead you to the correct answer. For number 4, you need to ask how many wavelengths can fit in each of these tubes, and you need to physically count how much wavelengths are in tube X here above the fluid and get a number or a ratio there, and do the same thing for Y, and then set them equal and reduce that ratio until you get the X represented as a function of Y. One thing you should note is that obviously the wavelength for Y is way bigger than the wavelength for X, so you should eliminate choices that don't show that. Number 5, from the notes, a transverse wave is not a longitudinal wave. A sound wave is a longitudinal wave and transfers energy only in one direction, or in the X direction, which would be in this way. Or in this example, the X direction of this slinky is up and down, whereas transverse waves, instead of being in the delta X direction, have their amplitude in the delta Y direction. So you should figure out which two choices could give you a wave that's direction is not up or down, which would be that of a sound wave. Number 6, you should remember from the free response that a pattern like this is composed of a wave that travels, hits a barrier, and is reflected back. So there are a wave coming in from the left and a wave coming in from the right. And this has 3 antinodes and is a string, as you are told. So you can find this formula for its wavelength in the notes for the formula for a string or open tube. And that should allow you to express the wavelength as a function of L, and knowing that there's 2 waves that come in together, one to the left and one to the right, that should give you the answer. Number 7 is quite difficult, classic AP, but not terribly difficult when you realize it's a Doppler effect question. The student standing by the speaker hears the true sound, whereas in this case the truck is approaching, and so the sound waves, or the apparent frequency it hears, it is compressing the sound waves, so the truck's frequency is higher, or in this case the time interval is smaller. The student must be in the middle because the student is hearing the true frequency, so you should eliminate A and D. That would give you a 50% shot of getting this right. Lastly, you know the car is pulling away, so the waves behind it must be expanded, and the frequency or apparent frequency heard is lower, i.e. the time interval is greater. Those combined should give you the